All right, let's dive in. Today, we're putting on our data detective hats. You look at a table of data, and it's just numbers. But what if I told you that with just 3 simple commands, we can make that data talk? We're going to unlock the stories that are hiding right inside.
Okay, so take a look at this. This is our starting point, a little piece of a data set about professor salaries. You've got rank, years of service, salary, but it's a total mess, right? It's just a jumble. Like, can you tell me who the top earners are just by looking at it? Or who's brand new? No way. The answers are in there, I promise, but they're buried in all this chaos. So, what do we do? How do you actually find those secrets? How do we turn this messy puzzle into something that makes sense? Well, it all starts with one simple idea. We need to create some order. And that brings us to our first tool, sorting. Seriously, this is pretty much the first step in any data investigation. It's all about bringing structure to that chaos we were just talking about. Think about it. You can't find a pattern if all the pieces are just thrown on the floor. You've got to arrange them first so you can even see what you're working with. Okay, so let's pose a real question, something that sorting can actually solve for us. How about this? Who are our highest paid new hires? Now, to figure that out, we can't just look at one column. We need to look at 2 things at the same time, right? Their years of service and their salary. So what is sorting, really? It's just a fancy word for arranging the rows in your data based on what's in a column, or maybe a few columns. The whole point is to push the most interesting stuff right to the top so it just pops out at you. No more hunting around. And check out how simple the code is in Pandas. It's just sort values. You just tell it what to sort by. For us, that's service first, and then salary. And here's the cool part. You can control the direction for each one. We want service to be ascending, so from lowest to highest, and we want salary to be descending, highest to lowest. Makes perfect sense, right? And boom, just look at the difference. On the left, that's our mess from before. But on the right, that's our sorted data. And would you look at that? The answer to our question, who are the highest paid new hires, is literally staring us in the face. It's the first few rows. The pattern isn't hidden anymore, it's crystal clear. Okay, so sorting is awesome for putting individual rows in order. But what if you want to understand the big picture? Like, what about whole categories of data? For that, we need to level up to our second tool, grouping. This is how we stop looking at individual trees and finally see the entire forest. And with grouping, we can start asking much juicier questions, like this one. Is there a pay gap between different professor ranks? I mean, that's a pretty important question, right? To answer it, we can't just sort. We need to figure out the average salary for each rank, assistant prof, associate prof, and full prof, and then put those averages side by side. And that is exactly where grouping shines. The absolute best way to get your head around this is to think of it as split, apply, combine. It's this super powerful 3-step strategy for making sense of your data categories. So let's walk through it. First, split. Pandas literally takes your data and splits it into little piles, one for each professor rank. Then, apply. It takes a function, for us, it's calculating the average salary, and applies it to each one of those piles. And finally, combine. It takes all those little answers and puts them back together into one nice, clean summary table. Split, apply, combine. So simple, so powerful. And you're gonna love this. The code is just as clean. You just tell Pandas to group by the rank column, then you grab the salary column, because that's what we care about, and then you just tack on .mean to get the average. That whole split, apply, combine process, all right there in one single readable line of code. And there it is, our answer. What's so cool about this is just how clear it is. You can see, just at a glance, the average salary for each rank. That pay gap we were wondering about? It's not a mystery anymore, it's right there in black and white. We've officially gone from a sea of data rows to a real powerful insight. Okay, quick little pro tip for you here, because this trips everyone up at first. See those double square brackets around salary? That's super important. If you use single brackets, you get back what's called a series. It's basically just one column. But if you use double brackets, you get back a proper data frame, a whole table. It's a tiny, tiny difference in what you type, but it completely changes the shape of your result. All right, so we've got averages. That's fantastic. But let's be real. An average can sometimes be misleading, right? It doesn't tell you the whole story. To get the full picture, we need our third and final tool, aggregation. This is how we get the complete, unabridged story of our groups. So let's push it. An average is a good start, but I want to know more. What's the range of pay for each rank? What's the absolute lowest salary someone's making, and what's the absolute highest? We need more than just that one middle number. And for that, we have the amazing ag-get method. It's short for aggregation. It's a lot like what we just did, but on steroids. After you group by rank and pick the salary column, you can just give ag-get a list of everything you want to calculate. You want the min, the mean, and the max? No problem. Just ask for them, all in one shot.
And there you have it, the final result. This is like the case closed moment in a detective show. We now have this beautiful, detailed summary that tells the entire salary story for each rank. We can see the bottom, the middle, and the top. This is a complete picture. So let's just take a breath for a second and look at what we just did. We started with a table that was a total mess, right? It was just noise. And with a few smart, simple detective tools, we've pulled out some actual clear-cut insights. And think about this. How many crazy, complex commands did we use? Not a whole bunch, just 3. That's it. 3 core ideas: sort, group, and aggregate. And with those 3, we literally transformed raw, meaningless data into real knowledge. So if you take away anything from this, let it be this. Sorting creates order. Grouping finds patterns, and aggregation gives you the full story. You put those 3 together, and that's how you turn a spreadsheet full of numbers into something you can actually make a decision with. And don't for a second think this is just a toy example for small data sets. This stuff is built to be fast. As the original material points out, these operations are vectorized and super efficient. We're talking about handling millions of rows without breaking a sweat. So these skills absolutely scale up to the real world, to big data. So I'll just leave you with this thought. Now you know how to sort, how to group, and how to summarize. You have the tools. The only question left is, what story are you going to uncover in your next data set?